Delhi under IIT Delhi and University of Queensland joint PhD program. So I'm the TA for this session. So let's go to the class. So as we all know that when there is polarization, or you can say when we take into account the move matter interaction in the medium, then our equation became is basically challenges for school the preschool. The whole equation became like this. So here we can say that this will be one as chi. And look like this. So when electric field is large, or we can say the amplitude of electric field is of the order of characteristic atomic electric field strength of electron in the atom, then we need to take into account the non-linear interactions. So how we can take into account. So P is basically P linear plus P non-linear. So the polarization can be written as understand characteristic atomic electric field strength is E by 4 pi epsilon naught A naught square, which is almost 5.14 into 10 to the power 10 whole meter. So for chi 2, to survive, chi 2 need to be as in the order of chi 1 by E electric field. So for condensed matter, chi 1 is of unity. Then chi 2 would be 1.94 into 10 to the power minus 12 meter per volt. Similarly, for chi 3 to have a significant contribution, it should be about chi 1 by E80 whole square. So chi 3 value should be 3.78 to 10 to the power minus 24 meters per minute square. So why this is square and this is only E80, we can know from this further configuration. So the polarization can be written as epsilon naught pi over E80 plus chi 2 is square E plus chi 3 E cube T. So on, so on. You can say that n e to the power n t. So the first term is linear, or we can say P1 term. Rest of the term polarization due to the yeah, no. So this is physical. So you can see here that chi1 E and chi2 E square should be of equal dimension. So basically chi1 and chi2 E should have same dimension. That's why chi2 is chi1 by E. Similarly, chi1 should have chi3 into E square. They should have same dimension. So that's why chi3 should be of the order of chi1 by E square. Then only we will get third order polarization component big enough that we can consider it as a perturbation of the main potential. So chi1 dimension of primary E is equal to dimension of chi2 square is equal to dimension of chi3 cube. So basically the dimension of chi1 is should be equal to chi2 and chi3 is good. So then only nonlinear polarization have significant contribution. Now you have already shown when not chi another thing is when the displacement of the electron in the matter is linear with respect to harmonic oscillator. Potential will say that polarization is linear. And when this displacement, which is the displacement of electron, when they interact with the wave, diverge from the harmonic oscillator potential, harmonic oscillator potential, then the nonlinear polarization is non-negligible. So we know that potential generally for harmonic oscillator is like this. It should be symmetric. So this is harmonic. But if potential became like this, okay, or something like this, then they are not harmonic oscillator anymore. So this corresponds to centrosymmetric media, and this corresponds to non-centrosymmetric media. So when the media is non-centrosymmetric, get both odd and even order polarization. So when we are taking non-centrosymmetric approach, and when medium is non-centrosymmetric, then we will get second order harmonic generation. And for the case of non-centrosymmetric media, the equation of motion of electron position is of the form like this. So in this equation, we have assumed that the applied electric field is given ET, and the change of the electron, charge of the electron is minus E, and then this is damping force. The gamma is related to damping force, and restoring force is minus m omega naught squared x minus m a x squared. So the potential became minus f restoring to dx, which is half of m omega naught squared x squared plus 1 by 3 m x cubed. So this corresponds to harmonic oscillator. And this term causes the non-centrosymmetric term. Now we could have like in void, you will see the equation, to solve the equation, and ultimately they get x like what would be the x1, x2, and so on and so forth. So basically the solution of the perturbation would be lambda x1 plus lambda squared x2, so on and so forth. X's x1, x2, x3 in the equation, and you will get different x values or different like x forms. And in week 11, professor has already covered those things, how we can solve according to perturbation theory, what will happen when field strength increase or decrease, something like that. Similarly, for centrosymmetric media, whose potential is curve. Okay, so this part and this part should be the same, almost same. Okay, that's why the name is centrosymmetric. So centrosymmetric media, they generally do not have even order polarizations. So for like centrosymmetric media, if the story is minus n omega naught square x plus nb x cube, and the potential is half of n omega square x square minus 1 by 4 nb x to the power 4. So you have noticed that here the potential is harmonic oscillator plus x cubed term, and here the potential is harmonic oscillator, it doesn't matter plus minus, but where it is x to the power 4 term. So the equation of motion of motion of electron displacement can be written as, so to avoid the confusion, you can write it in terms of r. So r plus 2 gamma r plus omega square r minus b r is equal to minus b t by n. So this term x cube, where we follow the notation of r cube, we written as nbx dot x into x. So that will be written as r dot r dot r. So when we solve this equation, we will see that R2. So remember here we have written x as a combination of x1, x2, then x3. So here we are following the notation of R. So R, let me write this. So our T is here, it is lambda R1 T plus lambda square R2 T plus lambda cube R cube R3T. So R2, when we do further calculation, we see that R2, R4, R6, they became 0. That means for central symmetric media, first order nonlinear response so for centrosymmetric media, we do not get SHG. We can say second order harmonic tau. So this is the like 2 omega plus omega 2 or 2 omega 2 plus omega 1, 2 omega 3 plus omega 1, something like that. But we will not get omega 4. Okay. Now just dive into descriptions of nonlinear optical process. So if the electric field the laser beam has electric field represented as ET is of e to the power minus I omega t plus its complex conjugate. Then we know the polarization became. So here remember how we define electric field. So we defined electric field as a E naught e to the power minus I omega t. This can be different from the notation in the class where it normal notation is e to the power I omega t and E star e to the power minus I omega t. Here e to the power minus I omega t, and this will be E star e to the power plus I omega t. So both is correct, but when you follow one notation, you should follow the same notation throughout the like not I will not say course, but throughout one particular like calculation at least. So see The energy level diagram of second order generation can be written as that they absorb one photon and another photon of omega, and they give 2 omega. We are discussing here second order harmonic generation. So polarization will become 2 epsilon naught chi 2 E star plus epsilon naught chi 2 E square e to the power minus I 2 omega t plus epsilon naught chi 2 E star whole square e to the power plus I 2 omega t. So this contribution have zero frequency, and these two contribution have at these two contribution are at 2 omega frequency, and this is second harmonic. The first contribution, that this term 2 epsilon naught chi 2 E star, it does not lead to the generation of any electric field or radiation. Why? Because second order derivation of 2 epsilon naught chi 2 is star is we all know. So the second order term should survive to get a electric field out of the medium. So that's the reason the zero order frequency will not give any electromagnetic radiation out of the medium. So what does it do? It creates another process which is called optical rectification. So and then always remember, not like this term. Any zero order frequency will not survive second order derivation with respect to the second order time derivative will vanish. So we will not get any electromagnetic radiation. But we will get another phenomenon called optical rectification, and why we need that. So maybe in the these week classes, professor has already asked the question if we'll get that zero order term out of the media. So I'll give you the answer: no, we will not get the zero order frequency out of the media, because the second order derivative with respect to time will vanish. But it will create an optical rectification, and this optical rectification further can help like a process of making terahertz source depend on optical rectification. So it's not the part of this course, but terahertz, 10 to the power 12 hertz So basically that counts 100 gigahertz to 10 terahertz region is called basically terahertz region, and why it is less explored in like for last 30 to 40 years it has been explored so much, but before that we didn't know how to generate terahertz and all those things. So basically this is one of the procedure to make a terahertz source. There are other kind of sources also, that one is QCL, then cyclotron can also create terahertz sources and terahertz radiation and all those things. So one thing is that under proper experimental condition, second harmonic generation can be efficient, that is so efficient that nearly all of the power incident at omega frequency converted to second order frequency to omega. So almost everything will convert to omega under proper experimental condition. Now so this is the special case that say SHG. This was SHG, second order harmonic generation. But most general case of second order polarization is some and difference frequency generation. So SHG or second order is basically some frequency generation when the input is only omega. So basically this is SHG. So this is the material. We put omega, and the material has omega 2, we will get omega and 2 omega. And if efficiency is so high, then all the omega will convert it into 2 omega. But for some frequency generation, the diagram is basically the material has guide 2. So we give omega 1 and omega 2, we'll get omega 1 plus omega 2 frequency. So like I have shown only one omega, that doesn't mean that only one like photon have with the frequency omega is hitting that thing. The source is one, and when I denote like this, that it doesn't mean neither the photons are one or the beam is only one. It doesn't work that way, that we like give only one beam in the material. So now the electric field incident upon second order non-linear optical medium is channel E1 e to the power minus I omega 1 t plus E2 e to the power minus I omega 2 t plus its complex conjugates. So basically, E1 star e to the power I omega 1 t plus E2 star e to the power I omega 2 t. So again, I want to tell you that in the classes, professor has already taken the field like E1 into e to the power I omega 1 t, and that complex conjugate is to be E1 star e to the power minus I omega 1 t. Both the notations are fine, both are correct, but when you like follow one notation, you should follow that notation all along the way. So here we come like assume that this is minus frequency, basically minus I minus omega 1 t, so that has the amplitude E1 star. So the polarization, second order polarization of the whole polarization. So always remember, when we are talking the nonlinear polarization, linear polarization is already happening. So basically, like it not like that when only non-linear polarization will happen, there is no part of like no linear polarization contribution. So linear part will be there. Along with that, there will be a second like non-linear part. See, here you can see that even with the non-centrosymmetric or centrosymmetric media, this area is almost follow the harmonic oscillator up to this area. So the linear part will be there. Like also you can say up to this actually almost. That have a like harmonic in the potential also you get the harmonic oscillator term. So always there will be a linear contribution of polarization. Then comes the nonlinear contribution of polarization. That is try to whole square. So we will get some terms that would be the epsilon naught e2 e1 square e to the power minus 2I omega 1 e plus e2 square e to the power minus I 2 omega 2p plus 2 e1 e2 e to the power minus I omega 1 plus omega 2t plus 2 e1 e2 star e to the power minus I omega 1 minus omega 2t plus complex conjugates of all those things. That means we have v1 star whole square to the power 2I omega 1t plus e2 star whole square to the power 2I omega 2t plus 2e1 t2 into the power I omega 1 plus omega 2t plus E1 star E2 e to the power plus I omega 1 minus omega 2t plus 2 epsilon naught chi 2. We have E1 E1 star plus E2 star. So this two term has zero frequency and it will not travel outside of the media because as we know that it the time derivative is zero. So we have seen that we have almost 10 terms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But the frequencies are basically 2 omega, omega 2, omega 2, omega 1 plus omega 2, omega 1 minus omega 2, and 0 basically. So we get basically 5 new frequency, including the 0 frequency, the polarization because of like polarization term which are vibrating with frequency 2 omega is epsilon naught chi 2 omega 2 is epsilon naught chi 2 A2 square. You have a frequency term also. And these are the complex amplitude of each frequency. And the complex term for omega 1, omega 2 is U epsilon naught I 2 E1 E2 and omega 1 minus omega 2 you get U epsilon naught I 2 E1 E2 star and polarization is determined E2 epsilon naught chi 2 E1 E1 star plus E2 E2 star. So these two are basically second harmonic generation. This is some frequency generation. This is difference frequency generation. And this is optical rectification. Similarly, we have negative non-zero frequencies also. So the complex amplitude of those things is epsilon naught I to E1 star whole square. So physically negative frequency doesn't have any meaning. But here due to calculation, we have those meanings. And due to epsilon naught I to E2 star whole square. So omega 2 minus omega 1 is basically minus omega 2. So that are the negative frequency part, negative frequency component first. So from these things, we get to say that we get four different non-zero frequency components. But typically, we will get only one of these component. Because of phase matching condition. So this condition can be satisfied for only one component at a time. So that's why only one component will be generated at a time. So here we have seen that P omega 1 plus omega 2 has the amplitude of this. So what is this application? So application for some frequency generation is produce tunable radiation in the UV range. By choosing one of the input waves, from fixed frequency visible laser and another from frequency tunable visible laser. For difference frequency generation application is produce infrared tunable IR radiation with visible laser. So I have already mentioned that. Okay, I have mentioned. So basically, some frequency generation can be denoted by like this. Then omega 1, omega 2, we get omega 3, that is omega 1 plus omega 2. And the material is chi2. So if this is omega 1, this is omega 2, we will get these of omega 3. But for difference frequency generation, it is basically omega 3 is equal to omega 1 minus omega 2, and that is like one photon absorbed to omega 1, it should be destroyed, and we will get omega 2 and omega 3. So basically, the atom first absorbs a photon of frequency omega 1, jumps to the highest virtual level. This level then decays by a two photon emission process, and one photon is of omega 2 and another is omega 3. So basically that is that one is only one absorption and two emission. Now let's go to third order non-linear optical process. So the third order polarization contribution can be written as like this. So the thing is that we will choose the electric field like in a laboratory E naught e to the power I omega 1 t plus. We will choose that, but first we consider the simple case in which the applied field is in monochromatic and is given the in t e cos omega t. So when we take Q of it. So polarization became 1/4 epsilon naught chi 3 V3 cos 3 omega t plus 3/4 epsilon naught chi 1. No, sorry, chi 3 E3 cos omega t. So we have taken the electric field of only omega. We could have taken e to the power minus I omega t, and the polarization we will get 3 omega component and only omega component. And because of that third order nonlinear polarization, we will get intensity dependent non-refractive index. And we will now see how the refractive index get modified, or they give self-focusing basically. So because of this, the effect is we get self-focusing. So, well, the material acts as a positive lens in self-focusing. So that can be illustrated like this. When into it at 0. So it causes n is equal to basically m0 plus n to I. So the intensity dependent refractive index is basically this part. And n2 is curve of the rays bend like this curve together one point, and this called self-focused beam. Um, and this phenomenon is very useful in optics domain. So now let's examine with like all the components. So P3T polarization is basically epsilon naught chi 3 in T. So E is basically E1 e to the power minus I omega 1 t plus E2 rho minus I omega 2 t plus E3 e to the power minus I omega 3 t and their complex conjugates. To the power I omega 2 t plus E3 star to the power I omega 3 t. So when we calculate the EQ3, we find the not E3, EQ3. It had 44 components. Including negative frequency component, and these frequencies are omega 1, omega 2, omega 3, 3 omega 1, 3 omega 2, 3 omega 3, omega 1 plus omega 2 plus omega 3, omega 1 plus omega 2 minus omega 3, omega 1 plus omega 3 minus omega 2, omega 2 plus omega 3 minus omega 1, 2 omega 1 plus minus omega 2, 2 omega 1 plus minus omega 3, 2 omega 2 plus minus omega 1, 2 omega 2 plus minus omega 3, 2 omega 3 plus minus omega 1, 2 omega 3 plus minus omega 2. So these are 22 frequencies, and these frequencies have also negative frequencies. So now I will write the complex amplitude of the nonlinear polarization for each of the positive frequencies. These terms are very important. Otherwise, I wouldn't have write those things. So corresponding to omega 1, we will get minus omega 1 also. Corresponding to omega 2, we will get minus omega 2 also. So for omega 1, the amplitude of the chi3 between 1 E1 star plus 6 E2 E2 star plus 6 E3 E3 star into E1. So they will cancel out omega 1. So omega 1 is basically omega 1 plus omega 1 minus omega 1, or omega 3 minus omega 2 plus omega 1, or this is omega 3 minus omega 3 plus omega 2. The amplitude for the omega 2 would be, shall I not? So that would be chi, shall I not, chi 3 6 E1 E1 star plus 3 E2 E2 star plus 6 E A3 star into A2. So basically omega 2 should be omega 1 minus plus omega 1 minus omega 1 plus omega 2, or omega 2 minus omega 2 plus omega 2, or omega 3 minus omega 3 plus omega 2. The third part of the frequency polarization due to the, like the, we get the polarization for the frequency omega 3, the complex amplitude for the omega 3, polarization for the complex amplitude of frequency omega 3 is like this: 6 E1 star plus 6 E2 star plus 3 E3 E3 star into E3. So omega 3 can be generated as plus omega 1 minus omega 1 plus omega 3, or omega 2 minus omega 2 plus omega 3, omega 3 minus omega 3 plus omega 3. Then we will get the third order harmonic. This is, we get only one combination of 3 omega 2. We get or omega 3, 3 like 3 omega 3, we get so one thing here that we don't need 3 frequencies to calculate this thing. You can work with omega 1 and omega 2 also. So for omega 1, 2 plus omega 1 plus omega 2 plus omega 3 is like this. Good. Two plus omega 3 minus omega 1 is 6 epsilon naught chi E E2 E3 E star 2 omega 1 plus omega 2 3 epsilon naught chi 3 E square E2 4. This is time taking, but each term has its own significance, and I will come to that. So from this term, you also get how the electric field is oriented. So it is E1 square into E3. And when we get to omega 1 minus omega 3, it is 3 epsilon chi 3 E1 square E3 star. Two epsilon naught chi 3 E2 square E3 E2 omega 3 minus omega 3 is fluid actually not correct. 3 into square the 3 star. Into omega 2 plus omega 2 is fluid actually not correct. 3 3 square into, and the last but not least is this component. So these are all the components, and they have their own like characteristics. If you want to go further of each component, like you can go in the point, but I do want to discuss these terms. Previously, I have stated that intensity dependent refractive index, right, in 2 plus I. So from which term it get generated? So from this term. So we are getting E1, but this is basically I1, this is basically I2, this is basically I3. So the intensity, this term is the intensity of field 1. So the field is modified by its own intensity. That is called self phase modulation. But this is I2. So I2 is modifying E1 also. That is cross phase modulation. Similarly, here this is cross phase modulation. This part is self phase modulation for E2. This is also cross phase modulation. And they changes the refractive index. So this like example is starts with 3 different frequencies. Let's go into something more like easy. First, to show on energy diagram, let us see omega 4 is omega 2 plus omega 3. So this third order harmonic generation, here also we get some frequency generation. These are called four-wave mixing. When it was like omega 1 plus omega 2 is equal to omega 3, that was the second harmonic generation, but it was three-wave mixing. So for this kind of thing, there will be an absorption of omega 1, another absorption of omega 3, omega 2, then another absorption of omega 3, and we get omega 4. And we can get omega 4 as omega 1 plus omega 2 minus omega 3 also, and the energy level diagram will be like this. That omega 1 is absorbed, omega 2 is absorbed, then emission is omega 3, and we get a omega 4 component as a result. So this is E1, E2, E3 star basic. So I want to discuss that how we'll get like intensity dependent refractive index. So n is basically n is media plus into I, and n is n, total n is n plus ik. This n is this, and kappa is related to alpha. So alpha is equal to alpha naught plus beta I. So alpha also depends on intensity. So chi total for centrosymmetric is chi linear plus chi third order into I plus chi fifth order into I squared, then that would be n 3 I square. That would be gamma I square. So this is cross phase modulation, this is side phase modulation. So similarly, we'll go with two field. So field is E1 to the power minus I omega 1t plus E2 to the power minus I omega 2t plus E1 star to the power I omega 1t plus E2 star to the power I omega 2t. So for that, we'll get some term like epsilon naught chi E1 star E1 into E1 and epsilon naught chi E2 star into E2. These are self-phase modulated term, and also we will get E1 star E1 into E2 and epsilon naught chi 3 E2 star E1 into E1. So these are cross phase modulation. By cross phase modulation, that basically intensity of the electric field 1 is modifying electric 2. Intensity of electric field 2 here is modifying electric 1. That is cross phase modulation. So for first do the cross phase modulation part. So we know phi omega is a function of omega k. So you can write this k with omega t. Always remember this k is not associated to alpha. Okay? Is not. This is wave vector here. So we can write omega by c in omega z minus omega 2. So here n square is basically 1 plus chi. So that is chi has linear part plus chi has non-linear part. So linear part chi is chi, non-linear part is chi q here when there is centrosymmetric material I. So n0 n is equal to n0 plus gamma I. So phi omega c n0 plus gamma I z minus omega t. So that is omega c and not omega z plus omega c gamma I z minus omega t. So this part was already there. The extra part was this. Don't get confused here. I have written alpha with a jockey beta, or here you can write it is a gamma. Okay. So we know instantaneous frequency is d phi dt. So delta phi is here omega c gamma I z. So delta omega is basically omega c gamma z di dt. So if intensity follow this profile, in time domain like this, then delta omega will be like this. So this reflecting lens for omega 1 would be n0 omega 1 plus gamma I omega 2 for cross phase modulation. And for omega 2 would be n0 omega 2 plus gamma. This is 1, 2, I omega 1. This is for cross phase modulation. Similarly, for self phase modulation, this thing changes. So what will happen for self phase modulation? For self phase modulation, n of omega 1 would be n naught omega 1 plus gamma 1 I. So let us gamma 1 I omega 1. So this gamma 1 and this gamma 1 will not be same. That's why I'm putting some dash or 0. So that is 1. This is 2. We need to put a dash. Omega 2 would be omega 2 plus gamma 0 to I omega 2. So here C for cross phase modulation, gamma 2 I. Okay. whatever I have written here, it is general. The I, we don't know which I. So when the different electric in I2 is affecting I1, that is cross-phase modulation. When I1 is affecting I2, that is I1 is affecting I1 itself, that is self-phase modulation. So for XPM, delta phi 1 is proportional to I2, but for SPM, delta phi 1 is proportional to I. That is the difference. So after when the self-focusing material we have type 3, so E1 is like this, you will get like a focus point. So this is called self-focusing. So from when third order nonlinearity is involved, you see the self-focusing, self-phase modulation and cross-phase modulation is happening. When self-phase modulation is basically when the intensity of its field like modulate its own electric field. That I1 is modulating E1, I2 is modulating E2, I3 is modulating E3. But when cross-phase modulation is when I2 is modulating E1 or I3 is modulating E1. That's our cross-phase modulation. So basically refractive index of E1 is depending on E2. So that is cross-phase modulation. And when refractive index of E1 is depending on intensity of E1 only, then that is self-phase modulation. So by changing the intensity of E1, the refractive index of E1 is gonna change, that is self-phase. But when you are changing the intensity of E2 or E3 and refractive index of N1 is refractive index of E1 is changing, that is basically cross-phase modulation. So both are phase modulation, both give us a self-focusing material, which I have shown that the E1 is going in a material and it would get focused. So I have discussed here some second order nonlinearity and how centrosymmetric media and non-centrosymmetric media works. If you want detailed calculation, you can go through the Boyd book. And which frequencies are generated when third order nonlinear polarization is involved, and why each components are important. Further, if you want to study each component, you will see because of these components, we will see another kind of phenomena. But for a gist, I have like show you how refractive index changes. Alpha is also changing in the same way. So that's for today. Thank you. And we have an extra class on Wednesday.